This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm Bryan Reinero. Jason Han is a DevOps champion and advisor to VictorOps. Jason writes, presents, and coaches on the principles and nuance of DevOps, modern incident management practices, and learning from failure. Jason is the author of ChatOps, Managing Operations in Group Chat, which deals with how ops teams can use group chat to enhance operation processes, and is also author of an upcoming book entitled Post-Incident Reviews, Learning from Failure for Improved Incident Response. Jason is also a co-host of the Community Pulse, a podcast on building community within technology. Welcome, Jason, to the show.
Thanks, Brian. It's been great to be a part of your show.
Despite our best efforts to deploy quality code on reliable infrastructure, outages still occur and often require human intervention to restore service. Having to respond to an outage, critical bug, or service interruption is an inevitable scenario engineers will face throughout their careers. Given the likelihood that we'll need to respond to an outage of some type, I'd like to discuss how we can prepare ourselves for failures. To kick off the discussion, I'd like to ask, what is an incident or outage?
You know, I think in a lot of cases it kind of depends on the company culture. But typically, most organizations, especially if they have IT services that they're relying on to provide some sort of value to either an end consumer, a paying customer, or maybe even just the customer within the company. Maybe that's someone in a different department that IT is trying to provide services to. Whenever there's a disruption in that service that takes down the ability for those end users or those consumers to actually leverage the services and do their work or get their job done, or in the case of an end user consumer, if they're trying to access, let's say, a website or a mobile app, and they're not able to accomplish what they're after, that's typically considered an incident, something that actually is disrupting the service that the business is trying to provide. And there's a lot of different sort of models that people use or different organizations use to sort of determine the severity of those incidents and what actually warrants a team responding to that and dealing with that. So there might be a Sev 1, Severity 1 type of outage, which is a more severe type of problem, or it could be something like a Sev 5 or something lower where, yes, something has been disrupted, but there's really no impact to the end user. Maybe something just isn't behaving like they expect. But generally, sort of the most widely accepted sort of definition of that is, are the services and the value that you're trying to provide to an end user being disrupted?
What kind of outages are likely to occur? In some cases, we might be deployed on a distributed system, but not always. What kinds of outages are typical that we see?
Usually outages occur when there's been some sort of recent change. Kind of one of the jokes we make within sort of the DevOps community is that the only root cause to an incident or to any kind of problem really is change. And that's it's two messages there. One, there really is no root cause within these large, complex, distributed systems. There's a lot of stuff going on all at the same time. And that's just sort of the nature of these dynamic and large systems, is that they're always changing. And one of the things that many organizations are doing now is they're increasing the pace of that change. So they're pushing new features out to production environments. They're making configuration changes and infrastructure changes on a very regular routine. So it's usually those changes that they try to push out into production environments that cause the initial problem. Maybe a bug wasn't caught. Maybe there was some sort of load testing that wasn't done. But yeah, in a nutshell, it's usually those changes that happen to a production environment that cause an outage. The second thing, or one of the next most common things, is going to be really just some sort of failure with a hardware type of item. So maybe a network switch has gone down, or maybe there's been a power outage. So something along those lines is going to be sort of the next thing that happens the most. And then another one is just simply humans. We make mistakes. We cause problems on our own simply by trying to improve things, trying to just interact with the software and the systems that we have. And oftentimes we just make a mistake and cause some sort of problem. And that can even sort of move into during the remediation phase. A lot of times people recognize that there's a problem and they go in to try to understand what's happening and try to clear up those issues and make them better and restore services. But unfortunately, a lot of times they actually end up making things worse. They go in and they start making changes to different configuration settings or trying to push new code out without it being thoroughly tested. And in a lot of cases, those might make what was initially sort of a small impact, low severity issue might turn into a larger one.
Interesting. That leads to another question is, how does the system let you know that there's a problem? How do we discover that there's an issue? Should we be actively tracking the system, polling it on a periodic basis? Or is there some other ways that we become aware of an outage?
Yeah, most of the IT professionals these days are leveraging some sort of monitoring service. And that could be something that's agent-based, maybe it's software that's running on different hosts or on different network routers or whatever, but they're able to poll those different devices, the different services, and find out the current status of that and kind of bring that information back to a central place. So in a lot of cases, those monitoring services, those monitoring tools are the things that actually detect the problems in the first place. Maybe it detects, there's been a spike in CPU usage, or maybe a hard disk is very close to filling up. That's, kind of critical to some sort of key component to a service. But usually, and hopefully, they've got some monitoring in place. And a lot of what the DevOps principles and this whole DevOps movement has really taught us is that we want to be capturing that data and have really good resolution, very good telemetry on what's actually going on with our systems, both hardware, virtualized infrastructure, what's going on with the applications, what's happening on the network, how healthy are our databases. So there's a lot of things that really kind of make up the backbone of a service that a company is trying to provide. And you want to keep an eye on all that stuff. But then there's also scenarios where, maybe an end user or a customer is the one who notices a problem first, and they'll submit, maybe a support ticket, or they'll mention something on Twitter, or in some fashion get in touch with the organization that's providing that service and let them know that they're having trouble. And then hopefully from there, whoever fields that initial ticket or that support request will then escalate that onto the teams that can actually begin the response process and start looking into what's going on. So those are kind of the main two. We hope that businesses are taking their services very serious, and they really do start to kind of up their game on the way that they monitor their infrastructure. And then from once you have something, keep an eye on your infrastructure and the applications. Then the next piece is really alerting the right person or right team and get some eyeballs on it and see if we can start understanding what the problem is.
I've found in some organizations that there's a failure that has occurred. It goes unchecked or unnoticed for a long time. And once it has been detected and taken care of, there's a response to that for avoidance of future problems is to have a lot of monitoring, to be quite noisy in the monitoring. That is to say that I've worked in organizations that had very noisy alerting systems. And there would be constant notification alerts. Probably the thresholds for alerting were set a little bit too low, with the hope that it's better to catch and dismiss than to not know at all. But it had a desensitizing effect on everybody who was on the alert list, all of the responders. How can that scenario be avoided, where we become desensitized to a noisy system?
And that's a great point. I mean, what you're referring to is what we call just alert fatigue, where there are so many alerts coming in, and in a lot of cases they're not actionable. They're just letting us know that something appears to be wrong. But if an engineer or someone actually goes in and starts digging around, they realize that this really wasn't a critical alert. This was something I'm glad I know about, but I probably didn't need to be paged for it. And so that case where we become desensitized to these problems, we actually need to start going in and tweaking the monitoring services so that they are only providing actionable alerts. And that's something that's kind of hard for a lot of teams. They kind of consider that technical debt. It's something that you need to do, but you never quite make the time or prioritize to go in and start adjusting those thresholds so that the person who's on call, if they're paged in the middle of the night, the last thing you want them to do is break, a good sleep cycle or something, only to discover that there really wasn't a problem in the first place. That in turn gets engineers kind of like you're saying, where they don't respond as quickly. Maybe they don't respond at all. So I think that the key to remember here is that, the measurement aspect that we understand is very important is something that has to continuously be evaluated. You really need to go in and make different tweaks and adjustments and improve the monitoring tools that we're using to make sure it really is dialed in and only alerting us on actionable problems. The flip side of that is that I think with sort of the proliferation of all of the tools that's out there, monitoring related tools, and of course the shift to the cloud, it's really kind of easy for people to over-monitor. And I'm not sure I totally believe that there is over-monitoring. I think there is over-alerting in a lot of cases, but I think the real value in monitoring, for the most part, comes in when you're actually trying to dig into what's going on, or maybe you're doing some sort of retro, the post-incident review that we were talking about for the show. When you don't have that information to go dig in and start to understand what really took place and see if you can find a trend, that makes it hard to understand how you can improve your systems in the first place. So I think one of the kind of the key messages that we hear from a lot of monitoring companies and specialists in this area is that, especially with as cheap as disk space is, the true value is capturing that data, not necessarily trying to alert on it on every single thing that seems like it might be a problem, but you don't want to not have that information available to you when it's time to start digging in. So monitoring can kind of provide two different things. First, you want to capture the information so that it's there, whether that's a time series database or something else. But you also want to make sure that the thresholds are adjusted properly so that if you are going to page someone in the middle of the night, it needs to be something that truly is critical, it's actionable, something really does need to be done. And then there's a whole other list of things and concerns that we need to make sure if you are going to page somebody, you want to make sure that they have the information and the context that they need to start evaluating what's happening. And you want to make sure that they have access into the systems that are having some sort of problem right now. If I'm being paged and I'm woken up in the middle of the night, and then it turns out I can't even log into the systems that are having problems, that's of no help to anybody. So there's a whole lot of other conversations to be had after the monitoring, but reducing that time to detect and that time to know that there's a problem is definitely one of the early challenges that a lot of companies have to figure out.
Let's take an example. In the case that you had mentioned that I might get an alert that I'm running out of disk space, and also making a quick distinction that monitoring is, of course, we're checking systems, we're keeping track of maybe system resources, disk usage, CPU, as you mentioned. But then alerting occurs when those metrics have crossed some kind of threshold line. In the case, as an example of running out of disk space, what would be an actionable alert that would allow you to take action?
Well, in the case of disk space getting large, first of all, I need to make sure that those thresholds are properly dialed in. And a lot of that you have to kind of remember, or at least consider what's driving maybe the increase in disk space. So for example, maybe on Friday night, our systems run a whole bunch of reports. And it's just part of a batch process where there's a lot of different things happening and files are being stored, and then they'll be processed and they'll be kind of cleared out of the system. If I'm being alerted on a bunch of batch processes that are going to be cleared out later, I'm going to have a problem with that, because that's actually part of our process, is to use up more disk space simply because we're trying to run reports. And so I need to keep in mind what's actually behind that disk space usage. But from there, if it really is a legitimate problem, it's not like I was just explaining some sort of reporting that's happening. The context that I want to know is this something that has happened over time? Did we go from 50% disk available to 2% disk available in about 5 minutes, or did we get there over the course of about 5 weeks? Because that's going to tell me that I have that's going to help me understand what kind of problem I'm dealing with, because those are two very unique scenarios. And one might mean our reports are running and these will clear out. And the other might mean that we just haven't really been paying that close attention to our disk space. And now here we are with 2% left, and we really don't even have enough room to start moving things around in a safe way. So the first thing I want to know is what's been happening over time. Give me that context. And then the next thing I want to know is what systems or services does this have potential of impacting, and is it impacting currently? So again, it kind of falls back into what additional pieces of information can you tell me? Is this disk space, the fact that we're starting to run out, what's the next domino or what's the next series of things that may happen if we don't respond right now or if we don't start remediating what's happening? So I want to understand a clear picture about, what are the impacts and what's going to happen downstream. But then I also want to start understanding what are my options from here. So one of the things that we advise for at VictorOps is that when you're alerted on something, there should be a run book associated with that alert. There should always be something that tells even the most junior person who may have just started at the company, this week, it should tell them where to start. What do you start to look for, and how do you access those systems, and which specific commands should be ran from a command line to, again, start digging into actually what's happening. And then if you find that this is the type of problem that you expected, and here's what you're supposed to do in the circumstances, what are the next steps after that? So there's a lot of different stuff, but it all kind of can be summed up into context. We really need to know more about what's happening, because an alert by itself isn't often all that helpful.
Yeah, it makes a lot of sense. I think it's worth also mentioning, too, that the threshold at which you set your alerts might be pretty important to review as well. For instance, I would say that if you get an alert when you're down to 2% disk space left, that might be too late.
Yeah, absolutely. And those are things that, you don't always stop and realize you need to go in and adjust those thresholds. Or, maybe if you're tired of being woken up in the middle of the night, finally you're going to just say, hey, I'm just going to go take care of this, even though it's not part of my normal work. It's not been assigned as a ticket within my system. It's not part of, this sprint or anything, but I'm not willing to deal with this anymore. And thankfully, the companies that take their post-incident reviews serious and they do some kind of retro after an incident, usually the discussion about what happened will surface those things. So you go through this retro process of understanding what happened and how did the team respond and what were all the different metrics that came up and the context that we had or didn't have. Then the conversation can start to switch around to, well, maybe we should go into Isinga or into Datadog or whatever monitoring tool we're using and start making some changes and actually schedule and prioritize that work. Otherwise, a lot of it just sort of gets lumped into, like I was talking about earlier with technical debt, and you just kind of never get around to it.
Yeah, good point. So talking about that incident review and report, there's an interesting aspect of learning from failures. And I think after an incident has occurred, sometimes there's maybe a nervousness about being at blame, or maybe sometimes even a desire to blame. And that can inhibit a fair discussion of what happened and learning from the failure. We talked about learning from system failures in episode 284 with John Alspaugh, but I want to further that discussion here. How can teams improve their incident processes by learning from previous failures?
Yeah, the whole conversation about blameless was actually something that I think Alspaugh, sort of came up with in the sense of the term blameless postmortems. And really what's behind that is that there are so many contributing factors to what's going on both before IT failure and during the response, that when we get into that retro scenario where we're coming together as a team and trying to understand what happened, our focus needs to stay on learning and trying to understand more about the system, including how the teams formed and responded and what they did during the actual incident as they're recovering services. And the problem with blame, although it's a very natural instinct for all of us, it doesn't provide any value. And so, most of us sort of in this industry are very guarded about our time and where we spend our energy. And we for the most part, have recognized, especially, I would say those kind of paying attention to the DevOps movement, that there's really no room for blame. In fact, it actually is more detrimental than good, because if you create an environment where it's safe for engineers to discuss what happened in a very open and genuine and transparent way, then you start to learn a lot more about what's actually going on. You start to uncover the differences between work as described and work as performed. A lot of us kind of know what should be done, but what should be done and what's actually done are rarely the same thing. And so you want to go in and actually understand all of that. And when we let blame or even different types of bias start to creep into those conversations, it's actually counterproductive. And so I think that's a big part of the conversations companies are struggling with, especially large conversations, because there's still a lot of people within organizations who have never really been exposed to these types of ideas, or if they have, they just didn't really feel like it had a place in business. There's always someone you wanted to hold accountable for problems, and there's always somebody who maybe their job was on the line if they caused some sort of major problem. The companies that are doing really well today, especially in the digital space and that kind of stuff, are the ones who actually kind of flip that on their head. And Etsy's a good example where Allspaw, was formerly the CTO over there. They had this sort of neat little thing. What they would do is if an engineer caused some sort of problem or made problems worse as they were trying to remediate issues, they were actually awarded this kind of a fun little prize that they just called the three-armed sweater. And what that was intended to do was really to give some attention and some sort of like recognition to the engineer who's actually exposed something very, very bad within our system. So we want to take this approach where, people and humans, we're fallible, we're going to make mistakes. And what we actually need to do is find ways for the system to work to our benefit and work around those problems. And when we introduce blame and we start to sort of go down these paths of counterfactual statements like, well, I would have done this if I just would have known, or I wish I should have, when you start using the woulda, coulda, shoulda type of language, that right there is a red flag that we're discussing a world that never happened and never will, and it's really providing no benefit to us. And that's kind of a hard thing for a lot of people to wrap their head around for many reasons. I think it's human tendency to want to blame someone and point a finger at a person when something doesn't go right.
Yeah, blame, you've mentioned, can be counterproductive. What is it preventing us from getting to the heart of? If there's either a fear of being blamed or just a culture of blame, what are we going to miss if we concentrate too much on assigning blame?
So I think a really simple example is, let's say, you and I were on an engineering team together, and for whatever reason, you ran a command from your laptop on your terminal that deleted an entire database, a production database. And it turns out we didn't have any backups. If we went in and started blaming you and just said, hey, Bryan was responsible for this, we need to make sure Bryan, for one, he needs to be removed from this role or maybe even let go from the company. If he's going to stick around with us, we need to give him some, a lot more training. We probably ought to put some more process in place and maybe make sure that this type of thing can't happen again. And so what that does is it actually, like I said, some teams will put in new process or they will, let somebody go. The first problem with that, if you're adding new process, that's really counter to what we're trying to accomplish through a lot of the DevOps conversations. What we're actually trying to do is look for friction in the system and remove that. We want to empower more engineers to have the tools available to them and the information and context available to them so that they're enabled to do the right thing. The second thing is that if I let you go for making a mistake, I then have to bring someone else in and train them on how the system works and all these different, nuance about how work gets done around here. When you already knew all that, and you also are now a subject matter expert on exactly what not to do to delete the database. And you can take that information and hopefully become sort of the champion of that and say, hey, I made this terrible mistake one time. Here's what we've done to try to, make it a little bit less of a thing that can happen. But you become that person who educates the rest of the company or the rest of the IT org on the right way to do things. And so there's financial impact if you have to remove somebody and then bring somebody in and train them and get them up to speed. And then there's also just you've removed that opportunity to learn because you've dismissed this person, you've got them out of the system, and all you did was come up with the fact that it was human error and that what we're going to do to remediate this is actually put in more process, which is counter to everything DevOps is trying to teach us.
Yeah, it seems that in cases like this, no one wants to be the cause of the outage. But if the person is eliminated because they had been a cause of the outage, you lose the ability for that person to ever share that experience and teach it to other people coming aboard, and maybe even prevent future outages by offering caution and experience.
Yeah, that's a good point. I mean, when you incentivize people to keep their mouth shut because they're afraid of the fallout, maybe, I witnessed Bryan being, let go for making a very simple mistake that really anybody could have made. Now I'm incentivized to keep that information close to my chest or the information that, I'm aware of, and like different pieces of the system and how stuff works and where there might be blind spots or where maybe there is access to a system that, maybe we shouldn't have available, or there's all kinds of stuff that engineers discover and just becomes part of their own knowledge. And when we let blame come in there and when we let people go because of mistakes, there's absolutely no chance of that knowledge transfer happening. There's no way for me or you to share the lessons we've learned because we've just slammed the door on that opportunity and said, well, this person made a mistake and so they got to go. And so, yeah, I mean, that's a great point. And I think something that a lot of companies fail to recognize is that there's actually quite a lot more value in a very open, transparent discussion about what happened, just, complete honesty about what happened. And if you can't handle that honesty, that's actually where the problem, I think, is.
Yeah, for sure.
This episode of Software Engineering Radio is sponsored by Datadog. Datadog is a monitoring platform that helps thousands of companies get visibility into cloud infrastructure, optimize application performance, and avoid downtime. Datadog integrates with more than 200 technologies so you can get immediate insights into all of your databases, your web servers, cloud services, and container technologies like Docker and Kubernetes. Start a free trial today at datadog.com/SERadio.
Let's talk about some diagnostic techniques. Let's say that we've gotten an alert and we know that there's a problem in the system. Now we've got to do some troubleshooting. We have to determine what's failing and how we can address it. We had talked about in episode 225 some problem-solving methods with Brandon Gregg. I wanted to get your impression that do you have a formal process for diagnosing and solving system failures as an alert is occurring?
I don't know that we have in terms of VictorOps, I don't know that we have a formal sort of process. I think in a lot of cases, process is a little bit squishy because we're constantly improving the way we do things. And also a lot of things that happen are very unique. This is the first time we've ever seen this. So if there's any sort of squishy process at all, first of all, it's, we got to make sure that we're getting the right people involved. And so there's actually 5 sort of full life phases within the life cycle of an incident. The first being the detection phase, which we've kind of already went over, where you've got some sort of monitoring in place, or you've got something that will tell you that there's a problem, even if it's a human that's detected it. And then we move into the response phase, which is actually about getting the right humans involved and making sure that they have the context. And so this is really kind of, I think, the area that we're talking about right now. And it kind of depends on the makeup of the teams and makeup of the organization. Do they have enough people on their engineering team so that they can share the load of being on call? If engineers have to be on call, 7 days a week and, for months on end, that's actually not beneficial to the overall value of the service that the business is providing. But if a company is pretty big, then you might be on call for 3 days out of a month, and that's pretty easy. So it kind of depends on the makeup of the company in how teams respond. But once they've actually been notified of a problem, the one thing we try to make sure is part of the process is that they are given that context. We want to make sure that there is a run book, and if there's not, that'll be surfaced in a post-incident review, and we can address that moving forward. But have that context surfaced. And then also make sure that you always have a secondary. So if I'm the primary person who is paged, I want to make sure that there's a secondary person on my team who I can reach out to when and if I need additional help. So one thing we always make sure is there's always a primary and secondary, because you never know, something will come up in that primary, you just can't get in touch with them. The next thing is that once it's been established that, we do have a problem. You want to try to understand what's the severity of this. Is there customers that are having impact to this problem? Is this just a blip and, we'll be back online really quickly? But really it's that whole triaging aspect of the response phase where we're just trying to understand what's going on, how long is this going to, are we going to be down? And try to just get to understanding more through this investigative process. And then from there, we can move into the remediation process, which, again, it kind of depends on the company. But maybe you want to start bringing in additional resources. Maybe you need to do sort of an all hands on deck type of thing and bring in a lot of people, especially if it's a high severity problem. And at that point, especially if you have a larger team, it might make sense for you to establish an incident commander during that one specific incident. And what I mean by an incident commander is this is a person who their role during that incident is really just to be sort of the traffic cop or somebody to navigate and make sure that the information is flowing to all of the different engineers and all of the different stakeholders so that everyone's aware of the same thing and everybody is working on different aspects of the problem all in parallel, and then coming back and reporting back into the team, hey, this is what I did, this is what I looked at, and this is what I saw. And so that, again, we're sharing that information. So multiple engineers can be kind of investigating in different ways, but that information is all coming back to a central place. And it's that incident commander who kind of manages that conversation and that communication flow. So I think an incident commander is often very important, especially for bigger incidents. And then once we get into, deeper part of the remediation phase, I think a lot of it just has to do with making sure that systems are accessible and that you've already hopefully established some sort of process for people to get into the systems that they need to, make sure that they have the logins and that if they need to establish a VPN, that they know how to do that. And, all of the technical aspects, a lot of that sort of has to be in place, or at least needs to be surfaced during the incident itself, hopefully in a run book. But beyond that, process of incident management, there's a lot of folks who kind of follow the sort of the firefighter type of mentality of incident management, which I think is very valuable. There's a lot of stuff that is very teachable in there. I think in a lot of cases, though, the language within that type of process is a little bit too command and control, whereas actually we want to empower individuals to do more, to understand the problem and actually start remediating the problem. But there's a lot of different ways you can go about it. I think one of the benefits, but also one of the frustrations for a lot of organizations about conversations around DevOps is that, one, the processes should always be improving. So we always have to evaluate them and see, is there another better way to do this? And two, it's often not prescriptive at all. So what works for us at VictorOps may not work for you. So it's really hard, especially when folks and companies come to me or come to VictorOps for advice on what are the quote best practices for incident management. We'll give them the things that are working for different organizations and the things we're hearing about shifts in the industry. But we try to avoid a very prescriptive approach because honestly, it may not work for their situation.
So it sounds like there's actually what you're describing as a kind of an incident lifecycle where there's the first phases are notification of a problem. And then there's trying to understand, characterize the failure or the incident, assignment of people to the incident. And then, of course, once the remediation is complete, maybe taking a look about what had happened and figuring out what the cause may have been for the incident. But that life cycle, it's interesting. It sounds like the way that life cycle is developed and maybe evolved has a lot to do with maybe company culture or the organization's culture.
It definitely does. We talk to a lot of companies. We have a lot of customers who, especially the enterprise, the larger ones who adhere to IT service management sort of best practices, or they follow ITIL. They've got a process in place that it's there and it's really hard to change. But they have to create a ticket within some sort of service management tooling. Maybe that's ServiceNow or Jira or something along those lines. But that's actually an early step in their process. Now we argue that that's actually detrimental to restoring service because entering in tickets and all those types of things, that's sort of, in our mind, the clock is ticking. And if you're not diving right in and or at least trying to get the right people on the problem, you're wasting precious seconds. And I think the average cost of downtime for a lot of companies is well over $5,000 a minute. So the extra time that you're putting in to create all these tickets and just, go through your process is actually harmful and, affecting the bottom line of the company. And so there's, like you were mentioning the full life cycle, a lot of companies, they don't really understand that life cycle because of the processes they have in place. And so when we talk about the detection phase and then the response phase and then the remediation phase, oftentimes that's sort of where it ends for them. Maybe they will do some sort of retro, but it's really just to try to identify root cause, which I was kind of joking about earlier. They have a process in place that probably has been around for years, but nobody's ever stopped to ask, is this helping us? And can we improve on this, in an almost daily manner? And so the next phase after remediation is the analysis phase. So that's where that post-incident review happens, or a post-mortem, whatever language you want to use. But you need to go in and analyze what took place. But I think where companies make the biggest mistake is that they do focus on the cause of the problem rather than how did we do? What was the time it took for us to know about this problem? And then did it take us 10 minutes to get, the right engineer involved, or did it take us 30 seconds? Because those are two different things, and they impact the cost of that downtime in a large way. And I think, unfortunately, with the bigger companies, maybe they can sort of absorb the cost of downtime a little bit more in some cases, but they don't go into that into that analysis phase, looking at it through the lens of how do we improve our response? Because to be perfectly honest, you might be able to prevent something similar to this problem from happening again, but it's an absolute certainty that something is going to happen again in the future. And it might look similar to this, it might look completely different, but if you're not going in and talking about how did we know about this problem, and how did our team come together, and what kind of information was surfaced, and did they have access, and all these different things, if you're not really, really digging into that, then you're never going to get any better at responding to problems. And that right there is, one of the biggest hangups for a lot of folks who are looking at ITSM and ITIL and saying, why do we continue to do it this way when it's been almost proven by, sort of what they call the unicorns out there, the Netflixes, the Amazons, the Twitters, that doing this type of analysis, what we're talking about, kind of this blameless mindset and just really understanding how the team's formed, that's actually causing these teams to improve, rapidly. And they're turning their engineers, I like to use the metaphor of a pit stop crew. If you're into racing and kind of understand that language, the cars run around the track all the time, and that's just part of normal operations. That's just part of the system. But eventually, something goes wrong. They've run out of gas, the tires have been worn down, they've got some sort of fender damage, and they need to come in and fix that stuff and get right back out on the road. That's sort of the new mentality of a lot of companies is we got to just know about these problems quickly and restore them quickly so that we can get back going. We don't want to, create tickets. We don't want to add more process. We don't want to blame people and not understand the system in a more holistic way. So it's that analysis phase that a lot of companies kind of skimp out on a little bit. They just focus too much on the root cause. And then the next phase after the analysis phase is actually the readiness phase, in which we kind of refer to as, well, you take all the things that you learned in your analysis, and then you go back and you improve your systems. Or maybe you start performing game days where you actually intentionally cause problems in a staging environment or some other safer environment, and just see how your teams come together and then talk about that. Because there's, like I said, there's so many ways teams can improve the way they respond to problems, but they never really give themselves that opportunity because they focus on the cause.
So it's as important to understand how well you are dealing with problems as it is to know what the problem actually was when an outage occurred. Not just what failed, but are we doing better about how we respond to failures?
Absolutely. Yeah, that's a big piece. Sometimes people they don't have the tooling in place or the metrics in place to sort of expose that. But if they're able to triangulate how long does it take us to know about the problem, and let's say that's 5 minutes, well, that gives you a number and some sort of mile marker to try to do better. It gives you an objective. Well, we detected this problem in about 5 minutes. Can we cut that in half? And then the next phase, that took us about 10 minutes or so, 10, 15 minutes to just get the right people involved. And is there anything we can do to cut that down? And then once we knew what the problem was and we knew what the impact was, really it only took us about a minute to actually fix the problem and restore services. Unfortunately, because we're really good at engineers and once we know about the problem and we're sort of able to grok the issue and what's going on, we can solve it pretty quickly. And that's rarely the problem. The problem lies in actually the time to know and the time it takes to actually form the teams and get them diving into what's going on.
Yeah, there's a lot of interesting stuff there. To kind of go into this a little bit more, let's say that there's an incident occurring right now, and we need to figure out how to respond, establish the severity, as you say. What kind of information should we be looking for that will help us formulate a hypothesis about what in the system is failing?
Well, so I think a lot of it sort of depends on your business. What is it that you're providing? The first thing I think a lot of companies do, especially those like those that are, we'll just call it a SaaS, those that are providing software as a service. The first thing they'll do is check how many people do they have logged into their system right now? Because you can, hopefully, this is something we didn't touch on, but I probably should have mentioned. One of the other metrics that's very important to keep an eye on is stuff that's related more to the business objectives. So hopefully businesses are keeping an eye on login requests and session times and how many people are in the system at any given time, and that establishes a baseline. So if, let's say, there's some abc.com company out there that's got, in general, they've got about, we'll say 100,000 people in their system at any given time, that's sort of the baseline. If that drops down to just like a couple hundred people, then we know, first of all, customers are being impacted because our logins or our sessions are way down. And so not only does that tell you that customers are impacted, but it also gives you a little hint into where you need to go look, because maybe you're dropping sockets, or some sort of WebSocket problem and people aren't able to actually establish a connection, or maybe the login page itself is down. So those types of measurements, those types of metrics are super important, but often overlooked. There's stories out there where really the service was operating just fine, but they were running, it's like an e-commerce business. And for whatever reason, they couldn't process, American Express transactions. And so to some people, the system was actually perfect. Hard drives are great, the network's fine, memory's all, looking good. But the fact is that there's a lot of customers who could not check out because we weren't able to accept American Express. And if you're not monitoring for that, you'd never know there's a problem. But that's another major problem that is actually impacting the bottom line of the company. And so I guess the point I'm trying to make here is that you can start to dig into some of these really like business-focused metrics to see, are customers being impacted? And also that might give you a little bit of a flag as to something to go look into. Like we can see people are not able to access our services. And then another good one, especially if we kind of stick with the story of SaaS companies, we see this all the time. Customers are not afraid to go on social media, especially Twitter, and actually let it be known that they're having trouble with that service. And so a lot of companies have to start monitoring social media and monitoring customer sentiment and making sure that their expectations are, the customer expectations are being met. And if they're not, then that also gives you a little bit of insight into where to start looking for problems.
Yeah, absolutely. One thing I noticed that you mentioned is baselines and knowing what your baselines are. In some cases, with some of the teams that I've worked with, the people monitoring or responding to, this happens in smaller companies as well, monitoring systems, they're not actually really sure what their baselines are. And the reason that this happens is in some of these smaller companies, I feel like the developer team has worked very, very hard to deliver a minimum viable product. And they reach that point, it's launched, but there hasn't been a great deal of communication between the developers and the operations team who are going to support that application in production. And therefore, they don't know much about the application they're supporting or what is normal behavior. How do you break down that siloed kind of environment?
That's a good point, and that's really kind of speaks right to the heart of the whole DevOps conversation is how do we dissolve those silos? How do we get the different units within an IT organization to collaborate and just work together a little bit better? And of course, the DevOps kind of points us to the developers, and the operations are the ones who really need to, get those conversations happening better. One of the we'll just call it a concept within DevOps that is very prevalent, and I think really helps teams understand one approach to this is this mindset of shifting everything to the left. We talk about shifting security to the left and shifting quality to the left. And all we really mean by that is rather than having quality or operations or whatever team that traditionally would only be brought in later in the life cycle, let's bring them in earlier, or let's bring in that action or that process. So let's do automated testing in the development environment, or let's bring in the security team and have them sit down with the developers rather than waiting until it gets all the way out into a staging environment and then security is like, nope, that's not going to work. Go back and try again. Let's move everything to the left so that we're actually talking about these things and thinking about these things much earlier in the process. And one cool sort of a byproduct of that is that as a developer, I will then start to understand the tooling that a lot of the operations teams kind of traditionally use, a lot of the monitoring stuff, or building out infrastructure using some sort of continuous integration tooling. If we start to move all that to the left and let that be a part of the developer's language and their tool set, then they become a lot more sort of invested in the service that they're building or that they're a part of building. But it also lets them become a lot more familiar with how these tools are used and how we can start monitoring for baselines and things that are important. Because as a developer, I have expectations on what it should do. But if I can start to monitor that earlier on in a scenario that kind of mimics what it'll look like in a production environment, then I know about that stuff a lot sooner. And I can have this greater sense of confidence on what are my applications supposed to do? What's the tool we should be using to capture metrics? Should we be using New Relic? Should we be using Datadog, some other application performance tool? But your developers become a lot more familiar and comfortable with that tooling much earlier in the process. And then one interesting kind of neat thing about that is that opens up the possibility of the developers owning more in production, which is something another part of the conversation with the DevOps is that people really need to own the service that they're building, and that doesn't just apply to the operations teams. They're not the ones who just own production. It's really everyone. But it's hard for everyone to understand it and really feel a sense of ownership if they don't even understand the baseline metrics. They don't understand the tooling that's capturing that metric and how to go in and look at it. So it's kind of like bringing all these cool tools and ideas and just moving it all the way to the very beginning of the life cycle of creating software and letting everyone be exposed to that, so that conversation just kind of evolves throughout the life cycle rather than just getting bolted on at the end of it.
Would you say that this is somewhat the function that a site reliability engineer would provide?
Yeah, absolutely. So site reliability engineering in general is kind of this focus on obviously the reliability of a service, the availability of a service. But a lot of people, if you start to talk about what a site reliability engineer does as a specific role, a lot of it just is kind of bringing these concepts, these DevOps concepts, bringing them in and sort of sprinkling them around throughout the different teams within the IT org, with, again, sort of having this lens of when we sit down to start writing code, I'm going to, as an SRE, I'm going to sit down with my developer and I'm going to make sure that, one, they're aware of all the tooling that's out there that we could use to create those baseline metrics and monitor the things that are important. But also they start having conversations with the developers about things like scalability and what's going to happen if we go from 10,000 users to 100,000 users. Is the way you're designing this piece of the application or the piece of the service, is it going to hold up for that? Because if it's not, then we need to rethink how we're doing this. And so the site reliability engineer is, in a lot of cases, it's a software developer who understands a lot of the operations type of work. In other cases, it's an operations person who has suddenly had this strong desire to start playing around with more automation and some of the things that are more or have traditionally been more exposed to just the developers. So it's kind of a blend of both software development and the operations teams where people come together, or one person will kind of bring those two aspects together and then kind of, I guess, disseminate that knowledge throughout the entire IT org so that as they are building the service, they're actually thinking more about how this is going to look in the future. How are we going to scale this? Should we be looking into containers? What are some of the friction points in our delivery pipeline? They start to introduce language like value stream maps and lots of really kind of interesting ideas that are really just intended to both break down the silos, remove friction in the system, but also get everyone on the same page about what are we trying to accomplish here and how do we all own this together.
Would this person, the site reliability engineer, also frequently be the incident lead for incidents that require group organization?
I think it kind of depends on the makeup of the company. I think in a lot of cases, you're right, that does end up being the role of a site reliability engineer during some sort of major incident. They can sort of play that middleman, that incident commander. But again, like I mentioned earlier, there's really no prescriptive approach to it. But the fact that that person likely has a pretty rounded knowledge of the system and different ways to approach it, they can be very beneficial being sort of that middleman, requesting, developers, go look into this, and security, go check out what's going on over here, and operations team, I need you to go look at this. Especially if the team really hasn't already kind of come together and they're already building that knowledge transfer and starting to all kind of understand and have better awareness. The SRE can sort of be that bridge in the middle that starts to get all those teams working a lot better together, especially during an incident.
So incidents, of course, don't happen in a vacuum. There's usually, as you had mentioned, there's a loss of business availability. And a lot of what we need to do, in addition to diagnosing and addressing the issues, is that we need to message status with stakeholders, business stakeholders. And when there's an outage, the thing that those business stakeholders seem to be most interested in is when will the service be back up? When will the service be restored? How can we provide reasonable estimates for time to recovery?
Well, one thing I want to point out is that you're totally right in that there are a number of stakeholders that are going to want to know what's going on, especially leadership. They really, in most cases, don't always care about the specifics of the problem. They just want to know how long they're going to be down, when is everything going to be restored. And so there are tools out there, status pages, that type of thing, that are really intended to sort of cross that bridge or get those people notified about what's going on. And so companies that follow kind of these modern incident management practices, they'll have engineers, or maybe it's the incident commander, go in and update a status page as soon as they have new relevant information so that they're constantly sort of sharing this information. Another big thing about DevOps is that they're always sharing, they're being very transparent about what's going on. And the stakeholders aren't always going to be just the leadership team or the people within the company. Stakeholders are also going to be the customers. And so they'll leverage things like status pages or even social media. And of course, sending out emails to customers to sort of update them on what's happening. But oftentimes it's really difficult to know when service is going to be restored. So I think that kind of speaks to why transparency has become sort of a very strong term, I guess, within DevOps, is that if me as an engineer, I'm working as hard as I can to solve the problem, but I still don't quite have an idea of when it's going to be restored, I need to communicate that, and I need to let people know what's happening. So there's been a number of actually kind of major outages. Amazon's S3 last year. There was a major DNS problem also last year. There's a number of sort of big incidents and outages that kind of made media this year or last year. And almost all of them, they never really know how long it's going to take. But what they did a pretty good job about is actually keeping the public or keeping their stakeholders engaged and up to date with what they know, what they're looking into, and as things change, they keep them all up to date in a very kind of continuous and repetitive way, so that me as an end user of Amazon's S3, I'm not just sitting around without any kind of information. I'm actually being updated on a pretty regular cadence. And that gives me some sort of comfort that, hey, they're doing something and they're probably doing it as quickly as they can, but at least they're not just sitting on their hands saying, we don't know what's going on.
Yeah, I imagine sometimes it can be difficult not being able to say when you expect to have service restored. I found that difficult sometimes to articulate that we're working hard on it, but we don't have an estimate just yet. We're still in that diagnosis phase.
Yeah, I think if you haven't gotten to the remediation phase of the incident, if you're still in that response phase where you're triaging, you're investigating, you're just trying to understand what's going on, there's no way for you to really know. It's not until you get into the remediation phase where you're actually taking action. And let's say I discovered, that we just found there was a major bug that's what's causing the problem. Well, we discovered the bug. We've now corrected the bug in our development environment, and now it's going through all of our automated testing, get through staging, and then get through all the different requirements before it gets into production. At that point, hopefully, because I'm pretty familiar with the delivery pipeline, I'm pretty comfortable in terms of how long does this process take. I, as an incident commander or whoever might go in and update that status page, that's exactly what I'm going to tell my stakeholders. We've discovered a bug. It has been corrected in our staging environment, and it's going through all of its automated quality testing, and it should be out in X number of minutes. But unless you have the confidence in your own release process and what your delivery pipeline looks like, and a lot of it's already kind of automated, so you have a very, very, we'll just say close estimate on how long it takes to get your code from development, staging, and then into production, it's really difficult for you to give any kind of accurate updates.
Now, from time to time, we may have to deal with someone, a customer or maybe a business stakeholder who's irate or emotional or upset or frustrated. How can we handle the kind of communication or interaction with someone who is upset and we're under stress, we're trying to diagnose a problem? Any best practices with dealing with people that are upset or angry?
Well, I think in a lot of cases, people are rightly upset, especially if, let's say, I'm a business who's providing some sort of API access into my system, and another business is relying on that API access and the services for their business. My outage may be causing their outage, or at least affecting their bottom line. So they're rightfully upset about what's happening. I think what we were just talking about, the transparency is your biggest ally. Letting the stakeholder, letting whoever is upset, let them know exactly what's happening. Let them know that we detected a problem and it was at this time. We've got engineers, we've got our best people looking at it. We'll update you as quickly as we can. Just being honest with them and being transparent about the process that you have in place is your first step. The next one is, if that person continues to come in and to be disruptive to the actual remediation process, then there needs to be someone, whether that's the incident commander or somebody else on the team, needs to be able to step in and sort of be the umbrella of the engineers and just let them continue their work. Because one of the worst things, or one of the most detrimental things to recovering from a problem, is shoulder tapping and context switching. And people coming in and asking for updates. What's going on? Give me an update. Tell me you're going to have it up. You're going to have things working in the next few minutes. That's actually detrimental to recovering services. So I think in some cases, you do need to have a person who can kind of run interference between internal stakeholders to make sure they're not actually slowing down the process that it's required to actually understand and recover from a problem. In a lot of cases, that could be the incident commander. It could be a senior engineer. It could be somebody else on the leadership team, understanding that they're working as quickly as they can. They're going to update us every time that there is something important to share. And we just need to be patient, because that's our quickest path to recovery.
So often the case is that support engineers or engineers who are on pager duty frequently or on schedule, they'll develop the most in-depth experience and expertise with the system, oftentimes hard won. They're also the ones that are probably at the highest risk of burnout. What can we do to prevent attrition of these experienced engineers?
Burnout is, one of the hardest things about incident management, I think, especially for teams who aren't able to really share the load, bring more developers on call and establish some sort of escalation path and maybe some rotations so that people aren't on call all the time. It happens all the time. We hear of people who just decide they don't want to be in ops anymore. They decide they don't want to be in software anymore because they've just had to respond to many problems. And so what we usually sort of advise companies is to start tracking. Let's make data-driven decisions here about even our on-call best practices. Let's make sure that if we've got a system that we want to maintain high availability for, that we take that very serious and we don't just dump it on one person or just a couple of people, because that's not sustainable. No matter who the engineer is and how talented they are and what kind of information that they hold in their head, it's not sustainable. And furthermore, it's not humane. And, that's another big conversation of the DevOps sort of movement, is that on-call practices need to be humane. You can't page people after hours for things that aren't actionable. You can't expect engineers to be on call, 20 days out of a month. You can't expect people to, have to miss their children's birthdays. You can't expect people to not take vacation. It's not a long-term sustainable plan. And so we try to educate companies and teams on tracking metrics. How long are people on call, over the course of a month or a week or whatever? How many incidents are they dealing with in that time? Because a lot of that, if they're on call for a week and they only got paged one time, that doesn't, sound too bad. But if they got paged every single day, that's going to take a toll on someone. So start paying attention to the metrics that are involved with your infrastructure. And then once you have those metrics, the other big piece is during your post-incident review, during that analysis phase, let's talk about what's going on with those engineers. Who was paged and how long have they been on call? Because if I'm the one who was paged and it took me 10 minutes to respond, that's a little bit excessive. That's a little bit too much. But if it turns out that during the discussion of that incident, we can surface, well, Jason's been on call for 15 days straight, that helps me understand why it took 10 minutes for him to respond. He's had to deal with this. He's the lone person responsible for responding to these problems for way too long. We've got to shift some of this responsibility around. So I guess the short answer to that is that, you can start making data-driven decisions on your on-call rotations and who's going to be responsible for what and how many days should they be on call in a row. And you just start to make smart decisions rather than just saying, well, you're in ops or you're an SRE, so you're responsible for being on call. That's not the path to high availability and reliability. That's the path to burnout.
I imagine that it's probably worth reminding engineers who wish to be helpful, don't force yourself to be a hero. Take downtime. Don't always respond to everything that's outside of your support rotation.
Yeah, that's a great point. Hero culture is one of probably the biggest harming kind of notions within IT. We really don't want heroes. We don't want the ninjas. We don't want rock stars. We don't want any of that. We want humans who are good at what they do, and we're going to treat them very well, and we're going to let them, be empowered to make the right decision. We're going to give them all the tools and what they need to do their job. But at the end of the day, we can't burn out our people. We've got to make sure that they do their best job, but we don't set expectations that are just too high and not attainable.
Yeah. Well, thank you very much, Jason. Just a quick question on your new book, Post-Incident Reviews, Learning from Failure and Improved Incident Response. Is that now published?
It is, yeah. We just released that, I guess it was a week and a half ago or so. It's available for digital download currently, and I can give you a URL for that. And then hopefully we'll have physical books here from the publisher within the next week or so, definitely by the end of, or by the middle of August, I'm told.
Terrific. Well, thank you so much for joining us.
Thank you. This has been great. Good to talk to you, Brian.
Good to talk to you, too. This has been Bryan Reinero for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.